actually know what is exactly inside those artificial neural networks. We have a model, but then we don't actually understand the output, the firing of neurons. So in that motivations, we try to take the perspective of this Boolean algebra. In our case, is two set. We take this relationship of two set, and then we map or govern this artificial neural network. So a little bit about general interpretation of Hopfield. So Hopfield consists of collective neurons that fires when excited. Okay, so general definition of HNS is given by this. Again, Hopfield, if you want to know more about the architecture of Hopfield neural network, you always can read J.J. Hopfield and Tang 1945. Okay, so it's a very pioneer or foundational paper of Hopfield neural network. Okay, so this is the the equations of the neurons, where Wij is the synaptic weight and Sj is the neuron state. So remember, Sj here, just want to let you know, it's something like a 1 and negative 1. It can take value of 1 and negative 1. 1 means on, negative 1 means for off. So you can also change your interpretation. Let's say if you think that, oh, I don't want on and off, yes, you can go true or false, or maybe you said female or male, so it's up to the user. All right, so yeah, we have an interpretation here, 1 and negative 1 here. So it is a summation of this multiplication of synaptic weight and Sj. So this particular symbol is considered as threshold. So this is Hopfield neural network was inspired by how our brain actually works. So let's say the product, the summation of the product of this does not achieve the threshold, means it cannot force the neurons to fire. Simple as that. So it inspires by how the neuron actually works. Right. So how we can connect this Hopfield neural network with the previous two sets, okay, is by implementing the two sets, and then we assign each neurons, okay, with the variable in two sets. Okay. So for instance, okay, for instance, let's say here you have A union negation B intersect with negation C union D. So in this case, we have 4 neurons. Okay, when we increase this, then we have 6, 10, 100 neurons. Right. So all these neurons are governed. All these logical rules will govern the artificial neural network or Hopfield neural network. So how does each of these neuron fire? So we are using equation 5 by examining the level of excitement. Okay, so it's very funny because neurons can have an excitement level as well. So it's very human. I can say it's very human. If we put it into layman terms, imagine if you are touching any hot surface. Okay, some hot surface you can actually tolerate the hot surface, but if you touch something that is very very hot, okay, it's extremely hot, then it will be go beyond your threshold, then you will do some decision, means you have to angkatlah you punya tangan kan. So basically that kind of uh, that kind of perspective is what motivates us to come out with this equation number 5 and number 4. Okay, and then another thing about artificial neural network, I realized that for the for maybe I have been in this work for 4 to 5 years. I'm still new in this field. I realized that one thing about artificial neural network is just one problem. Artificial, we just need to find what is the optimal synaptic weight of Wij. Okay, whenever you read any papers, okay, if you go to Science Direct, There are, I think, around 1,000, 2,000 papers, maybe 100 papers to 200 papers published on neural network. Okay, I can actually simplify all those papers into one simple sentence. The artificial neural network is the reason, I mean, the one that we want to find in doing artificial neural network is the synaptic weight. It can be defined in any terms. It can be defined in synaptic weight, connection strength, okay, weight, okay, and then it can be any weight. So if we are able to come out with the best weight, okay, configuration of weight, then we can safely say that we are able to come out with an optimal artificial neural network. So in this case, the synaptic weight for this Hopper neural network that we combine with the logic is based on one Abdullah method. So if you are interested to know more about one Abdullah method, feel free to go to the citation number 6, okay? So, or you can just go to Abdullah 1992. So they will give you the illustrative example on how to find the synaptic weight. And then when you compare with the logic, okay, this one Abdullah method helps us to reduce the possible error in Hopper neural network. We're going to see it later, right? Okay, now since we managed to find out what is the local field, okay, the local field will translate the neuron. Okay, imagine we have a neuron and then we have a local field. So local field will help us to drive the neurons from the initial stage to final stage. Okay, so here's the problem here. When you have a final neuron state, we want to find out whether is does the final neuron state is really the correct final neuron state. So in my opinion, actually it's not my opinion, it's according to Abdullah 1992, which is these references, you can actually find out the optimality of the new final neuron state by computing the final energy. So this is a Lyapunov energy functions. Okay, and what's so interesting about this equation is this Lyapunov energy function has a fixed value. Okay, it has a fixed value for two sets, for three sets, or maybe first order logic. So first, second, and third order logic. So it is a very good mechanism for us to decide whether your final neural state achieve optimal results or not, optimal neural states or not. Okay, so a lot of researchers, okay, especially in this field, they use this final neural energy to test the stability of the artificial neural network. So again, if you are interested to know more about the behavior of this final energy, you can always go to these two papers. Okay, so one paper is the foundational paper by Abdullah 1992, and then the other one is my current paper. All right. So this one also can informs you or maybe can teach you on, not say teach, I mean gives you some illustrations on how we find out what is the synaptic weight for the Hopper neural network. All right. Okay. So I don't know why. Okay. Anyway, so these are the implementations. First, we start, and then we translate all logic into Boolean algebra. So as we all know, logic can be in any form. Okay. So our job here is to convert the logic into Boolean algebra, because Boolean algebra is easy to be traced or to be read by artificial neural network. And then after that, we derive the cost functions. The cost function, okay, in this case is the consistency, the inconsistent of the logic. For instance, we have A union B. So A is -1, B is equal to -1 means it makes the A union B is not satisfied. So we need to find out what are the cost function that minimizes the inconsistency of the Hopper neural network. So from there, that is how we enter the learning phase of artificial neural network. I just want to remind you, artificial neural network consists of two parts. One is learning phase, the second one is retrieval phase. So a lot of researchers try to improve any of the perspective. So some people think that we can improve retrieval property. Yes, that's good. Okay, and then some people said we can also improve the learning phase. So actually, there's no right or wrong answer. It depends on what are you optimizing for. Okay, next is we check cluster satisfaction. Check cluster satisfaction is plays a pivotal role in this artificial neural network, because if you don't check your cluster satisfaction, there's a high possibility that the logic that you are putting inside the Hopfield neural network is unsatisfiable in nature. So this can be shown in the work of several work like there are several work by Sapersteven 2020, okay, where the logic that has been used is maximum satisfiability. So in this case, the synaptic weight that has been derived is not correct, okay. And then when you manage to find one interpretation, okay, let's say if you manage to get only one interpretation, then we can safely say that these logic are satisfiable in nature. Then we can use one Abdullah method to obtain synaptic weight. So from there, we can safely compute the minimum energy of the network. Okay, the minimum energy supposed to be, which is HP mean. So by computing the HP mean, the minimum energy, the synaptic weight, we can create the matrix of synaptic weight. All right. And just want to let you know, Hopfield neural network has symmetrical synaptic weight. Means if you consider the the matrix, okay, it has zeros and a diagonal, and then they have symmetric synaptic weight, and then it undergoes statistical relaxation phase. All right, so that we can give neurons some relaxation time, so that it can give us more optimal neuron states. And then we go for local field computations, upper scaling by H-staff. Okay, H-staff is hyperbolic tangent activation function. And then lastly, we will compute final energy. But of course, whatever, sometimes when we embed a logic inside Hopfield neural network, there will be some issue with storage capacity. It means that when we don't have, if let's say the iteration required to find the cross satisfaction is very less or it's not enough, then there's a high possibility that we cannot find the correct synaptic weight. So when that happens, this whole thing will collapse. When I say collapse, means the final energy is not stable. It will not reduce monotonically. So our aim here is to ensure each iterations will reduce monotonically until it reaches the global minimum energy. All right. So these are the general flow chart for logic into artificial neural network. Okay. So, all right. Okay. So let us visualize the final neuron state. Final neuron state is something like a minimization problem. So we have two perspectives. Okay, one is global minimum or optim or global minimum, and the other one is local minimum. So if you look at the flow chart just now, okay, our aim is to produce solution that is global minimum energy. So that's why uh, our our system, I mean our artificial neural network that was amended by logic must follow a very um, smooth iterations. Means from one initial stage to global minimum energy here. So that's our aim. That is our aim. All right. But again, when you increase the number of neurons, okay, when in this case we increase the number of variables, the logic can increase, right? The number of variables, then it's hard for us to achieve our global minimum solutions, right? So, all right. So after we already come out with logic, and then we put it into Hopfield neural network, we are creating Hopfield neural network that is governed by logical rule, right? So now By using those Hopi neural networks, we will implement the Hopi neural network into logic mining. So this is the scientific name. I mean, the specific name for logic mining is two satisfiability reverse analysis method. Okay, so let's look at the motivation behind this logic mining. The primary challenge in evaluating the data with predefined goal is how to extract the correct information that represent the latent information of the data set. So the key word here is latent information, because some data, um, some data will give us a hidden story about their patterns, about how the data actually behave. So what we're going to do, we try to extract the the logic from the data, from the big data, and then hopefully those logic can give us some information about how the data actually behave. And more importantly, not only gives us some knowledge about how the data actually works, we can use those logic to do classification also. All right. So when you have a new data later, you can classify what is the outcome of the particular data. Okay. So given a set of data, we have S1, S2, S3, until Sn. So these are the neurons, all right, which gives you one or negative one. Okay, and it's a number of attributes. So people might confuse with the word attributes. It's the same as features. Okay, can be considered as features, variables. All right, statistician always talk about variables. Okay, but in this case, I'm using the word attributes. All right. So the task of two satra, which is two satisfiability reverse analysis method, is to map learning neuron states into final neuron states. All right. So these are the possible permutations. Okay. In the example. So instead of just S1, S2, S3, S4, then you can actually put this S4 and join. Maybe you can change the couple here. Right. So this is the example of permutations that you can put before you put it into your Hopfield neural network. Okay. Next, in this case, this logic, since we have so many permutations, right? So you are putting all these permutation into a different Hopfield neural network. So just want to remind you, we only consider logic that is satisfiable in nature only. So so after we manage to put it into the system, or hop in your network. So the logic mining follows the following termination criteria. Okay, and then we will use those logic to find our induced logic. So right, okay. So this is the example. Okay, so basically we have a data. We convert the data entries to bipolar representations. So we can use any method. Actually, you can use k-mean clustering. You can use a lot of data processing methods. Okay, and then you can divide into learning and testing data. Again, this one is based on references. I'm using Hamatner et al. 2015 on the learning data and testing data. So a lot of people might have different opinions. Maybe you want to go for 70-30 or 80-20, but I prefer to have a bit lower learning data to validate my to validate my results. Okay, from the learning data, we will generate the best logic, which is p-best. Okay, so from there, we will calculate the synaptic weight by using one Abdullah method just now. And then after that, we have a configurations of synaptic weight, right? And then from here, we will do data extractions. We compute the local field. Remember the excitement just now with with a tolerance. And then we will compute the final neuron state. Before that, we will compute the final energy. So from there, we will check whether it is global or local. So, but again, we will do both actually. So for global mirror energy, we will create an optimal induced logic. So we will check, by using this testing data, we will check whether the testing data can classify. I mean, the induced logic can classify the testing data. Okay. Okay. So these are the experimental setup. So basically, Tusatra is a logic mining method. We will implement it in by using Microsoft C++, Express 2010 software. Actually, we also can implement this in a simpler tools like Python, or maybe you can use Dev C++ as well. But I prefer to use C++ because C++ is talking about line by line, right? And I don't like using built-in functions. Built-in function, maybe you have to change the background programming, which I don't really favor lah. Okay, we also run 100 trials with 100 neuron combinations. So these are the parameters and data set used in this simulations. Okay, so all these parameters are based on the previous studies. Okay, CPU time, h-stop, hyperbolic tangent activation function. We have causal noise, we have permutations, and so on. Right. Okay, so so actually there's a lot of data. We already checked. Actually, we already extract more than 1,000 data sets so far. Okay, my team, we already extract a lot of data sets. So in this case, I'm just taking only 3 data sets. Okay, so that we can see the interpretability of this logic. If I use a lot of data sets, then it will confuse a lot of people. And some of this data also already being published in, I think, in our recent paper, okay, in 2022, 2023. If you have time, you can check it out. So basically, we take from UCI data, which is German credit data, congressional voting records, and hepatitis. So these are the number of instances and the area. Okay, so we use 1,000 instances, and then we use lower instances like hepatitis data set. Okay, and then we have this attribute type, number of attributes. We took 6 out of 20 attributes. Okay, 6 out of 17, 6 out of 19. So there are some missing values, and then we divide 60-40% based on this. We just approximate 60-40. So these are the description. This is the outcome of each of the data sets. Again, we as a neural network practitioner, we try to be we try to be neutral when it comes to data. Means we just see data and then we know the outcome. We don't actually know the underlying reason of that outcome. For example, credit risk for potential debtors. We don't actually care who is the debtors, or maybe classify Republican and Democrat voters in the United States. We don't actually want to know the factor of why people do Republicans and Democrat and so on. We just give you an induced logic. Then it's up for the real practitioner to analyze it. All right. Okay, and same goes to this hepatitis. We just come up with this induced logic, and then we give chance to the actual practitioner, which is doctors or medical practitioner, to evaluate, okay, and to validate our logical rules. Okay, so yeah, so these are the data sets and these are the attributes. So the attribute is duration of credit, payment status, credit amount, value saving. Okay, so this one is more on the finance front, and the other one is all this lah. Okay, so let's look at the accuracy and the precision here. Okay, so in this presentation, we are making some improvement in terms of permutations. In this case, we will change the partner of the variables. Okay, so in this case, when you put the permutations operator, you will have a lot of induced logic. Means you increase the possible search space of the most accurate induced logic. So these are the induced logic. Number 1 until number 6 are the induced logic. The 7 is the current work. The current work is so simple, means you just put A, B, C, D, E, F in this arrangement. But what happens if you change the arrangement in so many permutation ways? You will get different accuracy. So what does this thing actually signifies? Um, we when we have a variables, okay, when we have, let's say, certain variables, some variables uh, can connect with other variables, although they are not connected in the standard logic mining. So when we test all possible variables, then we will see the accuracy actually change, right? So same goes to the precision. Okay, so yeah, we can say that the permutation operator actually increase the accuracy level. All right. Okay. The next one is congressional voting records. You see here, if you look at the standard, the value is 29.41%. What will happen if we add permutation operator and it increases up to 94.12%? And then the interesting part about permutation here is we can find the lowest value of accuracy, which has a good agreement with maximum satisfiability. So it creates a research gap to this field of studies. Okay. So next is, yeah, this is hepatitis data. For the standard is 35.4, and 1 until 6 year, it managed to give us 80.95 for accuracy and precision 95.31. It's a big jump in terms of accuracy. Of course, we also check different performance metrics such as what you call this, MCC, right? F1 score. We already put it into yeah, our recent publication. All the possible confusion metrics, performance metrics. Okay, so we actually undo we already prepare somewhere around 6 to 10 performance metrics to see whether our performance work is has a good accuracy or not. Okay, so these are the existing model. So when I'm creating these slides, okay, we are actually comparing it with different types of existing model. Although this found it all, do it all, and cortex this, all these 19 until 21, they are not logic mining. But since we have to compare with the existing model also, so we can see that our new to Satra actually outperform the existing model. So these three are from the existing model. And how do we choose this model? Is we have to validate the reliability of the model. Okay, and some model they use the same data set, but then the outcome is not. They are doing clustering um, problem. They are not doing any classification problems. So we discard that kind of model. We only take model that is very near to our model. So as you can see here, it increased lah. Okay, all right. So as a conclusion, HNN model can be incorporated with P2 set, and then from that, when you put it, the logical rule as I mean, when you put 2 set as a logical rule in Hopi neural network, it creates a predictable finite neural states, because the finite neural states can achieve global minimum solutions or correct solutions. Okay, and then the finite neural states can actually, you can actually increase the solution space by putting permutation operator like we have put just now, and then from there, when you put it into logic mining, it actually increase the performance of that logic mining. Okay, and then these permutations to Satra actually outperform the conventional to Satra and other existing model in the literature. So I think these are my references. Okay. So okay. So I think one of the things that that is very interesting in this field of studies is these studies, this I can say these studies is still in infant stage. We are still new because we are trying to have we are creating we are trying to create artificial neural network in the perspective of mathematics, okay, and physics. So there are several potential research directions that I would like to offer to the audience today. So I put it into four domains. Okay, the first domain is feature selection. So for the selection, if you see our work in this presentation, we are using random selection. Okay, we randomize the selection of the attributes. It works sometimes, but it doesn't work most of the time because some of the attribute is not important, right? So for the feature selection, you can actually use other feature selection such as log linear analysis. Okay, log linear analysis has been popular, popularly. I mean, it's so popular because a lot of people try to extract the features using statistical methods. Okay, and you can also go for correlation analysis. Let's say if you have 100 attributes, and now you want to extract only six, so you can use correlation or regression. Okay, you can also use similarity analysis like Jacob and so on. Okay, and then you can also use normalized mutual information (NMI), okay, to avoid redundancy of the attributes. So these are the feature selection part. A lot of people, if you look at the previous or recent work, they try to optimize logic mining by implementing feature selection. Okay, in the phase of training or slash learning, we can also create a, an effective mathematics algorithm, because in order for you to come up with the check satisfactions, you need to ensure it has less iterations. So in my point of view, you can always use EA, the election algorithm, or artificial colony. And we can also propose multi-objective type of meta heuristic. Means instead of just focusing on minimizing the cost functions, you can also increase the diversity of the solution. Why do you need that? Because if you increase the diversity, you are increasing the synaptic weight configuration. So it will give some benefit in during the retrieval phase. And then for the retrieval, okay, I think this is the part that most of the people in my field uh, always neglect, but for me, it's so important. You can also put diversity operators such as mutation, EDA, all right? And then you can do Mr. HNN to control synaptic weight. So I know one Abdullah is so powerful, but then if you want to move forward, you can actually propose Mr. HNN to actually change the synaptic weight. So when you change the synaptic weight, the interesting part here is the local field, the level of excitement will be changed as well. Then you get a very different final neural state. And then lastly is the logic structure. So I cannot emphasize this enough. Anything, whatever that, whatever network, artificial neural network, it starts with the logic structure. So if you are able to come up with a very flexible logic structure, okay, flexible in terms of systematic, non-systematic, or you instead of going for only satisfiable, you go for non-satisfiable, like maximum satisfiable satisfiability logic or minimum satisfiability logic, you always can cover more search space. And when you are able to cover more search space, then you can represent the testing phase in optimal way. Hence, you increase the accuracy, F1 score, and all the performance metrics. So these are the four domains of possible research direction that um, I can suggest to the audience, right? Okay. So yeah, so these are my details. Okay, you can get this in Google. You just Google my name and put USM expert, then you will get all this. So basically, our research, okay, actually this research has been translated into more than I think more than 80, 60, so in this case, 80 publications. So Alhamdulillah. So since this is still an infant stage, there's so many things that we can improve on. So the one that I showed to you just now is just it's just a tip of the iceberg lah. Means there are a lot of things you can consider, like logic phase. Okay, you can also consider the cross a lot of other experimental setup to increase the performance metric. So again, if you are interested to know more about this research or to do collaborations, I highly recommend you to email me, or this is my phone number. Okay, this is my personal phone number, or you want to know more about me, you can always go to my website. Right? Okay, I think that's all from me. I would like to pass back to the moderator. Thank you.
Thank you. Terima kasih Dr. Syahrizwan di atas perkongsian yang sangat menarik dengan banyak maklumat yang diberikan. Dan mungkin dalam kesempatan ini, sekiranya ada soalan, ada pertanyaan, boleh kemukakan. Is there any question? Can ask directly to the speaker. We open for Q&A. Mungkin tak ada. Mungkin saya sedikitlah saya tanya doktor, mungkin pada permulaan tadi doktor kata ada gabungan antara fizik, fizik, matematik dan sains komputer kan?
Ya, betul. Betul. Betul.
Bagaimana yang tu saya agak ni.
Okay, gabungan tu dia macam kita ada 3 gabungan. Physics tu dia dari segi logik, okay, Boolean algebra. Betul lah, dia ada matematik sikit, tetapi kita belajar tu dalam peringkat physics lah. And then kita ada computer science dari segi artificial neural network, kan, computer science tu. Lepas tu kita ada mathematics. Mathematics tu yang equation tu semualah, Lyapunov energy function, symmetric weight, concept addressable memory, matrix, semua tu. So kita create bridges lah, kita create jambatan antara 3 bidang ni. Itulah kita buat satu inovasi lah dari segi data mining. Jadi saya harap menjawab soalan doktor lah.
Yeah. Mungkin ada soalan lagi? Ini ada soalan, boleh silakan. Okay, saya rasa ada soalan di ruangan chat.
Okay, do you think the logic mining works well with the infusion of other ML or statistical approach? Okay, so that's a very good question. Okay, thank you so much to the audience who are posting this question. So in my opinion, logic mining, it all boils down to no free lunch theorem. So since we are operating based on NP problem, yeah, non-deterministic problem, you have to try first. You have to try the ML or machine learning. Then we know whether it is compatible or not. And it differs from case to case. Sometimes this particular case is not compatible with this ML or not. But in general, ML, okay, or statistical approach like correlation, indeed, it improves the logic mining. So to answer your question on whether it works well or not, generally it works, okay, because I have a paper that published on the statistical approach. But I also have paper that say the otherwise, like some statistical approach like log linear. It works to some extent, but then when it comes to the complexity issues, it actually burdens the logic mining. So yeah, we have to we have to do the trial, the experiment to validate those performance. Okay, since we are operating based on non-deterministic problem. Yeah. Oh, okay. I have another question here. Overfitting is the main predator in data mining. How do you tackle the issues of overfitting issues in logic mining based on your findings so far? Okay, thank you so much for this question. Yes, I can agree with this overfitting. Overfitting definitely makes us makes the particular ML or artificial neural network to produce wrong output. Okay, so to solve this issue, one of the way, I mean, the current way that we use is we try to choose a better performance metric. For instance, a lot of people do use accuracy method. Okay, but in my opinion, I some people, I mean, some model can give up to accuracy 1, and then they said that their model is good. Okay, sometimes I agree with that statement, but then there is other performance metric that works better than accuracy, which is MCC, Matthew Correlation Coefficient, MCC. So this MCC helps us to determine whether the model actually overfits or not. So how do you tackle the issue of overfitting? It's very simple. You need to identify whether your model is overfit or not. Okay, then that's why you have to use MCC. Okay, instead of going for the accuracy, you have to check your MCC also. MCC is simple. Instead of accuracy, sometimes you get 100% accuracy, but then when you check MCC, it's 0.01 accuracy MCC. So it means that your data, I mean your prediction or classification overfit. So in that case, your model is not as good, it's not better than the random classifier. So to tackle that issue, there are so many domains, there are so many answers to this question. One of my perspective is you have to improve your logical loop. Okay, the logic mining, the word logic mining, the root of all logic mining is the logic. So currently, one of my students is proposing Y ran to set. Okay, Y ran to set. So Y ran to set for me, in theory, is very good because it can represent both systematic and non-systematic. So in that case, we can reduce the possible overfitting issues in the induced logic. And of course, you have to conduct more tests like cross validations to ensure that your induced logic is not only fit to certain solution only. So I hope I answer your question. Okay, another question. Thank you so much for your compliment. I only have one question. What makes logic mining model better than existing classification models such as random forest and decision tree? Okay, so for me, logic mining, by the word itself, logic mining means that it creates, I mean, we extract logical rules. So by that features alone, it makes logic mining model better. So if you go for random forest decision tree, by the end of the simulation for this method, you're not going to get logic. So they just give you some form of decision, okay, whether die or live, or maybe female or male, or maybe they give you final outcome. They don't give you exactly how do they arrive to the final outcome. So when we have logic, okay, that has been extracted from the data using logic mining, we can know what are the attributes that affect each of the variables that contributes to the outcome. Yeah, so yeah, that's my opinion. Okay, and then another one is, oh, okay, thank you. Yeah, kudos to Inspem team also for the proposed sharing session. Okay, another one is for wire and set, when it only consists of one set, we'll create more FN. How to improve the accuracy? Actually, one of the ways, in my opinion, this is a difficult problem also. In my opinion, your logic, I mean, your system must be comfortable to do a lot of permutations. So currently, we only permutate within the variables only. We don't include the outcome. So what if we are able to include the outcome in our permutation also? So that's one way to ensure that the first order logic actually contributes towards the induced logic. So permutation, that's one of the way. Okay, and then the next one is The Y-RAM2 Satra, for me, you can actually use mutation operator. So some people will say, okay, to Satra, S to Satra is very good. Okay, this has been supported by so many people. S to Satra is very good. But then we can also portray the two-set logical rule that has been produced by Y-RAM2 Satra contains mutation operator and mutations or different sets of English logic. Then when you compare, and then you see, okay, S to Satra produced this English logic. Y-RAM to Satra produced this English logic. Both are two sets, but then they have different negations. So that is how you actually improve the accuracy. And then another thing is, if you try to improve accuracy, you're not going to go anywhere. I think, in my opinion, the best performance metric in classification model is MCC. Okay, MCC, because you can have a very good accuracy, but the MCC is very low. So when that happens, you will have an overfitting issues, right? So, but again, I'm not saying you need to have a low accuracy. You need both. You need to have a balance between MCC and accuracy. So not only accuracy you need to improve, you need to improve the MCC as well, or maybe F1 score, any other performance metric. Okay, so I hope I answer your question.
Okay, terima kasih sekali lagi kepada yang bertanya dan terima kasih juga kepada Doktor di atas perkongsian yang sangat interaktif ini. Dan dalam kesempatan ini saya cakapkan terima kasih dan insyaAllah mungkin dalam masa siri lain kita terjemput lagi doktor kerana apa ni doktor sudi untuk menerima jemputan kami insyaAllah. Dan insyaAllah kita akan jumpa lagi pada siri akan datang.
Terima kasih Dr. Haizat kerana invite. Okay.
Assalamualaikum. Waalaikumsalam. Bye-bye.